Kia ora everyone. Today in this presentation, we are going to talk about how artificial intelligence or AI is helping protect our wildlife in environment. So let's start with the introduction part. AI is a smart tool that can think and learn like humans. Conservation groups are now using it to solve really big problems like tracking animals, stopping poachers, and help nature recover. So in this presentation, we will show you why we needed AI, what problems are solved, and why it's so important for future of our. Before AI was used, wildlife conservation faced some serious challenges. Firstly, some animals were at risk due to heavy loss, poaching, and the growing effect of climate change. These threats were making it harder to protect endangered species. Secondly, the traditional methods like manual tracking or using field researchers were often slow, expensive, and couldn't cover large areas effectively. Lastly, it was very difficult to monitor animals living in remote or wide areas, especially in forests, mountains, or deep ocean zones. So these issues created a strong need for better, faster, and smarter solution, and that's where AI came in. This issue is very important because all animal plays a role in keeping up the nature balanced. If one species disappeared, can affect many others and break the food chain. For example, if predators go extinct, prey animals can overpopulate and damage the environment. Also, healthy forests and animal help up fight climate change. Tree absorb carbon dioxide and animal keep the ecosystem strong. So protecting wildlife isn't just about saving animals, it's about protecting the planet and our own future as well.
After the massive 2020 bushfires in Australia, WWF faced a huge challenge: how to monitor wildlife recovery across such a vast landscape. Their project, Eyes on Recovery, led to the setup of over 1,000 motion sensor cameras in affected areas. These cameras generated over 7 million images, and the majority of them didn't even contain animals. Most were triggered by weather, like wind or rain, which made manually viewing them nearly impossible. It would have taken years to sort through all the data. That's why WWF partnered with Google to use Wildlife Insights, an AI powered platform that automatically removed blank images and flagged those containing animals. What once would have taken years to process was now done in just a matter of weeks, saving time and allowing conservation work to continue without. So, how did the AI actually work? Wildlife Insights use machine learning and computer vision to identify over 1,300 different species, even from small parts like an ear or the tip of a tail. This allowed WWF to track specific endangered species like the greater glider and analyze biodiversity recovery after the fires. While the system wasn't designed for anti-poaching, it was incredibly useful for large-scale wildfire monitoring and real-time image analysis. Instead of researchers sorting through images by hand, the AI delivered insights instantly. This kind of speed and accuracy meant WWF could respond faster, make more informed decisions, and scale up successful conservation strategies, like installing artificial nest boxes based on real evidence.
Now let's look at the specific AI technologies that make Wildlife Insight so powerful. At the heart of the system is Google's TensorFlow based SpeciesNet model, trained on more than 65 million camera trap images. It uses deep learning to filter out blank frames and then identify over 1,300 species, even if all that is visible is a tail or an ear of an animal. This happens in the cloud using Google's AI platform predictions, allowing processing speeds of 3.6 million images per hour, around 3,000 times faster than a human could even manage. So let's look at how the AI actually analyzes the data. So when the WWF post bushfire images are uploaded, the AI first detects whether an animal is present. If yes, it classifies the species based on patterns it learned, such as fur, markings, or shape, even in partial or blurry shots. High confidence matches are automatically accepted, while the uncertain ones are flagged for human review. This semi automated workflow combines AI speed with human accuracy. There are many advantages to this approach. It saves years of manual work, delivers near real time biodiversity data, and allows WWF to see changes in species population as they happen. For example, it was used to confirm that the endangered greater glider was using every nest box that was installed for them after the bushfires in Australia burned down the hollow trees they used to live in. It also creates a global platform for sharing data between conservation groups and making large scale wildlife monitoring more coordinated. But it's not without its limitations. The AI works best on species it's been trained on, meaning rare or underrepresented animals could be misidentified or missed. Even with 94% accuracies, false results can happen, so experts' oversight remains essential. And because the analysis is cloud based, reliable connectivity is needed for quick processing in remote areas. Overall, wildlife insights transform massive amounts of raw camera trap data into actionable insights, turning what was once a slow, resource heavy task into a fast, collaborative tool for protecting biodiversity before it's too late.
By integrating AI into wildlife conservation, it will improve monitoring and protection for wildlife, it will have a better resource allocation, and it will gain more accurate data, which will then lead to effective conservation efforts. And over time, we should hopefully see endangered species thriving and ecosystems recovering. So, looking long term, using AI in this capacity will have a very positive impact. Industries like healthcare and agriculture can also benefit from AI's ability to make fast data-driven decisions similar to those used in wildlife conservation. They can also use similar tools to complete repetitive tasks, like how AI is used to monitor habitats and the wildlife. For example, in healthcare, AI can be used in a similar circumstance, like a diagnostics tool that could automate tasks that would otherwise be very time consuming. And in agriculture, it can be used to detect weather changes for crop growth.